Hello, everybody. I'm Mirjam Miner, and I'm from Goethe University, Frankfurt. Due to Hurricane Beryl, I was not able to present this work at the International Conference on Case-Based Reasoning, the ICCBR 2024. So please enjoy the video on retrieval augmented generation with large language models for explaining business process models. I've done this work together with my student, Eduard Kaucher. In case-based reasoning, there is a subfield called process-oriented case-based reasoning, which focuses on business process models and workflow management. It applies and extends the traditional CBR methods, for instance, to provide modeling support for the process designers, to retrieve process models, or to monitor their execution within a workflow management system, and more recently also to provide adaptation methods or transfer learning methods to transfer a business process model from one application domain to another. All those methods have in common that they target mainly professionals in business processes, for instance, business analysts or modeling designers. However, we observe that the normal user, the normal participants, like the staff members from HR departments, are frequently struggling to read those graphical models. For them, it would be very beneficial to have a textual explanation in addition to the graphical model. So a solution idea is to use generative AI to verbalize such models, and in addition to explain some concepts of the process models at a meta level. That means the elements of the modeling language. A naive approach would be just to serialize the graphical model and then to prompt it directly to a large language model to generate a textual process description. BPMN is a modeling language that stands for Business Process Model and Notation. And here is an example of such a model, beginning with a message from a customer who wants to be processed a loan request. The first step of this process is that a risk assessor service is invoked that assesses the risk of this loan approval, and depending on the outcome, it decides either that the risk needs more review, that is the left-hand branch, where another loan approval is invoked that considers the loan approval in more detail, or in case of a low risk, it is directly approved, or in case of a high risk, the loan approval is denied. And what we would like to have is such a textual explanation on the right-hand side. Here an explanation created by a human that first explains the content of the process step by step. So the loan request process begins when the customer sends a request and so on. But in addition, explains the elements, the visual elements that can be seen or that are depicted in the process model. For instance, how to interpret a message start event, or what a service task is, what an exclusive gateway means, and what an end event denotes. Our research question has been inspired by other case-based reasoning researchers like Hammond, Leakey, and Watson, who formulated that a case-based memory could be investigated for large language models. So the general research question is, which role case-based reasoning could play for generating explanations of structural models such as business process models? And a more specific research question is, which case retrieval approaches are appropriate, which are most beneficial to support the retrieval augmented generation for the downstream task of explaining business process models. First, some foundations and then our approach. Large language models, or LLMs, are a probabilistic model for the generation of text. So that means that a model P predicts an output Y for any input X with respect to the parameter C of a model that has been learned in advance. For instance, for a neural network that has been trained based on large amounts of data. And instead of pre-training the probability distribution of the XY pairs directly, the training learns how to predict the text X itself by means of the parameters theta. The target function of the training is to maximize the likelihood of the overall training corpus. That means of all linguistic units U that are considered within the context of their predecessor tokens. That means the sum of all logarithmic probabilities of any UIs based on the preceding units ui minus k until ui minus 1. So k denotes the size of the context window that is considered when predicting the probability of any ui. This model can then be used in an autoregressive fashion to predict a new token ui within the context of the predecessor tokens. So for instance, if you see a sentence, I get so sentimental from your blue ... then the predicting model replaces the ... by any linguistic unit, for instance by eyes or hair or even VW Beetle with a lower probability. Prompt engineering is then the task to find a good prompt, to define the best prompt to solve a task with the large language model. For instance, the task of creating an explanation for a business process model. The solution approach is based on retrieval augmented generation, which means that the generator module, the large language model, is combined with a retriever module that stores some knowledge that is beneficial for prompting. So according to Kattab et al. From a blog from Stanford AI Lab, this helps to decouple the capacity of the LLM for understanding the text or generating the text from how they store the knowledge that is required for doing so. And case-based reasoning is a quite natural way of providing a case-based memory in form of the case base, a collection of cases with experiential knowledge that can be accessed by means of a retriever module using a similarity function to detect the best matching case for a recent user query such as a BPMN model. We have investigated two variants of such a case-based memory for the task of explaining business process models. So the first is reusing indexing knowledge from the case base. That means the problem part of the cases, the indexing knowledge on the business processes themselves to divide large prompts into several parts. This is called case-based prompt chaining. And the second approach, approach B, is using the entire cases as in-context examples for the generation of explanation. That means that we store cases as problem-solution pairs and use their solutions to solve the downstream task. Variant B seems to be the most direct CBR for RAG approach in a classical sense, where experiential knowledge is used to solve new problems. And variant A aims to address the limited context window size of recent LLMs. I have to admit that variant A was not so successful, but variant B provided very good results. So I will focus on the variant B in the following slides, but both variants provide in-context learning. That means they do not fine-tune the probabilistic model, which is a bit in contrast to the work of Lewis et al., who introduced the RAG term. Here for the variant B, we see a sample prompt template in the language Python, which can be used for a GPT-4 generator, and it uses a retrieved case as an in-context example. So if you have a look at the lines 15 and following, 12 and following, you see that here two variables are to be filled with the two components of the retrieved case, namely the problem part and the solution part. The problem part is the BPMN model serialized to XML, and the solution part is the explanatory text. Further, we have the user query. Here the problem part of the new case, which is formed by a title of the BPMN model and the BPMN model itself to be explained. We have an array of different messages prompted to the generator module. First, the system role, which describes the perspective that the LLM should consider when doing the task. So here it describes that it should take the role of an Q&A system with expert knowledge on the BPMN modeling language and so on. And the second entry is the user role, where the actual request to respond to is described, namely to create a textual process description for the given BPMN model. In line 10, the F indicates a Python function that replaces the variables by their attribute values, that fills, for instance, the example BPMN XML with the according retrieved XML snippet from the case base. The prompting is done in an iterative manner. You see on the right-hand side the LLM in the black box, which uses the prompt that I have shown on the slide before as a first input, where the retrieved case number 1, the best matching case, is inserted into the prompt, and the original query from the user. And then the result of the LLM, indicated by the black arrow, is integrated into the next prompt, the prompt 2, together with the next best matching case, the case 2 from the retrieval result. And this is prompted in an iterative manner so that at the end the K best matching case is refined into a final answer. That means that the LLM creates the answer in a refinement process step by step, in each step using a different case from the case base. We've conducted some experiments on this, on an implementation with the orchestration framework Llama Index, where we orchestrated the generator module with the ChatGPT-4 and the retrieval model by means of an embedding-based similarity measure, cosine similarity measure, that using OpenAI's embedding model, text embedding ADA002, and tick token as a tokenizer library. We have an experimental case base with 37 process models from different application areas, including human resources processes, insurance claims, or supply chain processes. So a lot of different variants of process models from real applications. And we compared our retrieval augmented generation approach with the native LLM approach that I have shown on one of my first slides, and investigated several configurations of the regs, one for the best matching case only, that means k equals 1, one for 2 best matching cases, and one for 3 best matching cases in 2 runs of each configuration. The performance of the output has been assessed in a semi-automated manner, which uses precision and recall metrics, first in a pair that focuses on the model elements, so have all model elements been explained that occur in the process model, so all the activities, all the gateways, all the events, etc. And as usual in information retrieval, the precision focuses on the relevant elements that occur in the result, divided by the elements that are in the input, in the explanation, where relevance means that a model that occurs in explanatory text has also to be present in the process model. The recall then measures how many of the relevant elements have been actually found or have been created. We have also specified recall and precision metrics for the meta explanations. That means for the types of model elements, how many of them occur, and also for the order of the model elements, called pos. That means whether the model elements in the explanatory text have the same order than in the process model. And we counted also the semantics of the model element types. That means how many explanatory sentences on BPMN's meta model occurred in the explanatory text. This is not really a measure, since it can be the number of explanatory sentences can be larger than 1. The results first show that we were not able to conduct the results for all our models, or all our 37 models, since some of them have been too large to fit into the context window. So 33 of the models fit into the context window, which makes a case base with 6 cases and a number of queries of 27. So we arbitrarily divided the process model into those 2 amounts. And 27 queries have been asked to the LLM, to the retrieval augmented method on the LLM. But however, 5 of them could not be processed correctly, or the computational time was increased so tremendously that we stopped the experiment on those. So they all had more than 72 model elements, which simply made too many tokens to be processed in a reasonable time. But if you are familiar with good practices on process modeling, you know that such models are too large also to be understood by human beings. So usually a rule of thumb says that a model should fit into one sheet of paper. So they definitely do not fit into one sheet of paper. So for the remaining 22 queries, we combined the precision and recall metrics into an F1 score. And as you can see in this table, on average, the REC approach achieved better results than the naive LLM approaches for all of the measures. But if comparing the different REC configurations, you also see that taken into consideration more than one in-context example does not improve the quality of the results, or it improves it only marginally. In addition, we learned some lessons and made some surprising observations. So the first observation is that setting the temperature parameter, which is intended to avoid hallucinations, did not work as expected. So setting this parameter to 0 did not prevent the LLM from creating variance during the experiments. The second observation is that inserting meta-knowledge into the prompts does not increase the results, the quality of the results. So several authors in the literature have done this, but it seems that ChatGPT-4 has maybe seen already a lot of BPMN models, so that the concepts are inherent in the model or have been trained already. The third observation is that the context window size cannot be exploited at full size. So the larger models achieved very superficial explanations. So at random locations in the process model, some elements have been condensed, for instance, into one explanatory sentence, which is not very beneficial for users who want to receive explanation for the process model step by step. That means there seems to be a capability threshold that is lower than the official context window size. The last observation is that the optimal K, the number of K retrieved cases, is 1 at the moment, and that the improvements for larger numbers of retrieved cases are not worth the effort at the moment, at least. Maybe also due to the limited context window size. In summary, we have presented a retrieval augmented generation system that uses problem solution pairs from a K-space as in-context examples and improves the quality of generated results greatly when explaining business process models. In our future work, we would like to consider more sophisticated evaluating metrics, maybe based on benchmarks that are occurring at the moment, such as the Reckers framework, for instance. We would also like to investigate explicit adaptation knowledge instead of prompt chaining only. We have observed that the prompt chaining leads not to an adaptation of the results, but to a regeneration. So maybe inserting adaptation instructions into the prompts would help to have a real adaptation instead of regeneration only. And we would like to create multi-language explanations, for instance, in German language or in Bulgarian language, to address additional user groups, for instance, in further application domains. Some ongoing work is already in the explanation of structural models in medication plans for patients who want to know when and how to take some drugs. This could be also interesting for healthcare professionals who work in the care sector and have to create many medications for the patients and want to know some additional information on the medication plans. Or also in the medical domain, explanation of vaccination books. So when does a vaccination expire, or which vaccination is appropriate for a certain country where the patient wants to travel to. So I think there is a lot of opportunities to extend our work on the explanation of structural models. But also fields like software engineering or project management are promising, since there are plenty of structural models like database schemas or UML diagrams or semi-structured requirement documents, for instance, user stories that describe requirements of users. In project management, it could be maybe useful for latent staff members who come into a project late and want to know the state of a current project. So thank you for listening to this video. In case you are interested in further details or the references I've used during this talk, please have a look into our paper, which has been published at Springer, or go to our website and have a look there. I will also put the PDF of this paper, a preliminary version there, so that you can see also some ongoing work and the results of our further consideration of retrieval augmented generation with case-based reasoning. Thank you and take care.